Okay, so today we're going to be talking about angle bisectors and triangles. First off, we want to talk about the definition of an angle bisector. So an angle bisector is a segment, line, ray, etc. that bisects an angle of a triangle. So remember, bisects means that it cuts in half. So it's either a segment, a line, a ray that is cutting an angle of a triangle in half. So like in the picture, the example of this would be this ray right here, which is cutting angle P into two little angles. This angle here and this angle right here. So if it is bisecting, then that actually means that angle, and let's highlight it because some of us struggle with this on the test, angle APC, this angle right here, is equal to angle CPB, this angle right here. So we're going to write APC, we'll use is congruent to angle CPB. Okay, so a theorem that we know about angle bisectors is that if a point is on the bisector of an angle, like C, then it is equidistant. And so we've talked about what equidistant means. That just means an equal distance from the sides of the angle. So if I'm looking at this big angle right here, APB, and C is on the angle bisector, which it is, then that means that this length from A to C is equal to this length from C to B. So I'm going to put tick marks right there to remind me that those lengths are equal. Okay? And so it also shows you right here, AC is congruent to BC, which means part equals part for that. Now, the converse tells me that if a point in the interior of an angle is equidistant from the sides, so right here, if a point in the interior, C, is equal distance from both A and B, then it's an angle bisector. Okay? So it shows us, because of these tick marks, that both of these lengths are equal. Okay? So not only does it tell me that this lies on a bisector, but it tells me that PC is a bisector. So I'm going to add right here, then the line is an angle bisector. And so if it is an angle bisector, then that means that this angle equals this angle. So APC is congruent to BPC. Here and here. And that means either part is going to equal part, or if they just gave me this part and then they gave me the whole, we could do 2 times part equals whole. So these are not new formulas, and we should be able to identify what to plug in for each. Now, the second definition that I want to talk about is the incenter of a triangle. And I'm sure you've never heard of that because I hadn't either until I got to geometry. And that is just the point of concurrency of 3 angle bisectors of a triangle. Okay? So you probably don't know what the definition of concurrency means either. And concurrency is just a point where lines intersect. Okay. And so if we're looking here, the points where all the lines intersect is this middle dot right here. So that is the in-center of the triangle. It is where all three angle bisectors, so if I look at the angles, I have angle B, I have angle C, and I have angle A. Now the bisectors coming out them, all of them are intersecting at this one place called the in-center. So I'm going to label this in-center. Okay, and so the in-center of a triangle is equidistant. Remember, that means equal distance from the sides of the triangle. So I have side BA, I have side BC, and I have side AC. What it's talking about being equidistant from them is if I came from, and I'm going to highlight this so you know why. If I came from the in-center to side BC, I would go straight down. So it's talking about that length right here. It's also talking about if I came from here straight down to AC, from the in-center straight down to BA. Okay? Not only are all of these equidistant, which means they're congruent, so this line, and this line are all equal, but they also all make right angles or 90-degree angles. Okay? And so over here, they highlight PX, so from the in-center, which we let be P, from P to X, from P to Y, and from P to Z, all of those are equal. Okay? So we're going to use these three things that we learned to solve some problems. So let's look at example 1. So in number 1, it gives me this tick mark in this angle and this tick mark in this angle. When you have both of these, that means that they are congruent. So I could put tick marks. And if these are congruent, then it means this line from K to M is an angle bisector. And if this is an angle bisector and M lands on it, then that means that the distance from this point to the side of the triangle is equal to this point to this side of the triangle. So they asked me to find LM. If JM is 7, that means LM is also 7. Okay, so this is the first thing that we talked about above. Okay, now looking at number 2, they want me to find measure of ABD. So ABD, if I was to highlight, remember we start here, go to B, go to D. The angle we're looking at is where these two highlighted places intersect. So I'm looking for this angle right here. Now, looking at my angle ADC, it doesn't tell me that these angles are congruent, but it does show me that from this point to this side is 74, and this point to this side is 74, So these are congruent, okay? Which means that this line right here is bisecting both these angles and they're bisecting these angles. Okay, so it tells me that DBC right here is 51 degrees. So if this is an angle bisector, that means that my angles are going to be congruent, and so ABD would also be 51 degrees. Okay, let's look at number 3. So in number 3, the first thing that I see is that the distance from the angle bisector to the sides are the same, or the distance from the point to the side is the same on both, which means that this is an angle bisector. So these angles are equal and these angles are equal. They asked me to find angle TSR. So TSR is actually this whole angle right here. I know that this piece is 48. If it's a bisector, this piece is also 48. So to find TSR, it would be this whole angle. So I'd have to add 48 plus 48, which would give me not 76, but 96. Okay, now in number 4, we're going to have to take all this information that they give us here and fill in. So the first thing that they tell me is KD is an angle bisector. And so on your sheet, KD is this right here. So if this is an angle bisector, then that means that this angle and this angle is equal. Okay? Then it tells me that ADK, so A to D to K, this piece right here, or this angle, is 7x plus 1. Then it tells me that measure ADJ, so if I start at ADJ, I'm looking at the whole measure right here. The whole measure is ADJ, is 20x minus 22. So this was a whole, or the whole angle, and this was only part of an angle. So if we look back at, or look above at our formulas, we have a part equals part and a 2 times part equals whole. The 2 times part equals whole is the only one that uses a part and a whole, and so that's what we would have to use here. So we would do 2 times 7x plus 1 equals 20x minus 22. So from here I would multiply 2 times 7x, which gives me 14x, and 2 times 1, which gives me a positive 2. I would bring down 20x minus 22. Then I would start solving for x. So I would subtract 14x from both sides. This would give me 2 equals 6x minus 22. Then I would add 22 to both sides, trying to get x by itself. That would give me 24 equals 6x. Then we divide by 6, and x equals 4. Okay? Now, they wanted us to find KDJ. So KDJ KDJ is this angle right here. So they didn't actually give me a measure for this angle, but because it's being bisected, this angle and this angle is the same. So this can be 7x plus 1 as well. So we can plug in for that. We would do 7 times 4 plus 1. 7 times 4 is 28. 28 plus 1 is 29. So KDJ would be 29 degrees. Okay, let's look at another example kind of like that. So number 5, we're going to start off with our information and we're going to label everything. So the first thing tells me that RO is an angle bisector. Okay, so RO is this line right here. It is an angle bisector, which means this angle and this angle is congruent. So we got that taken care of. Next, it tells me that MRO is 8x minus 3. So if I start at M, go to R, go to O, the angle between those two sides is this. So it's telling me that this is 8x minus 3. And then it tells me YRO. So if I start at Y, go to R, go to O, it's talking about this angle right here is 5x plus 18. So I'm given half and half, or a part and a part. So if I'm given part and a part, we're going to plug it into the equation part equals part. So we're going to do 8x minus 3 equals 5x plus 18. I'm going to solve for x, so the first thing I want to do is subtract 5x from both sides. That's going to give me 3x minus 3 equals 18. We're going to add 3 to both sides. That gives us 3x equals 21. And then we're going to get x alone by dividing by 3. And so that means x equals 7. Now, the very last thing we want to do is we want to find MRY. So MRY is talking about this entire angle right here. So I could find a part and then multiply it by 2 because they're the same, or you could add these two together and then plug in x. I'm going to plug into 1 and then double it. So we're going to do 8 times 7 minus 3. And so 8 times 7 is 56 minus 3 is 53. And since I need it twice, I'm going to multiply it by 2. And so that's going to equal 106 degrees. Okay. Now flip to the back and let's look at 7. Okay, so in number 7, it tells me that TL is an angle bisector. So TL is this line right here, which means this angle and this angle, they're congruent. Okay. Then it tells me that GTL, so if I started at G, went to T, went to L, this angle right here is x squared plus 3x. And then it tells me GTO, so GTO, that's talking about this whole angle right here. Actually, let me highlight that in a different color. This whole angle right here is 5x plus 10. So this was a whole, and GTL was a part. So the only formula that uses part and whole is 2 times part equals whole. So that's what we're going to plug it into. So we do 2 times x squared plus 3x equals 5x plus 10. So we're going to distribute this 2. That gives me 2x squared. I'm going to distribute my 2 to 3x, which is going to give me 6x equals 5x plus 10. Now, anytime we see x squared, that should automatically set off an alarm in our head that says we're going to have to factor. So in order to factor, I need to get everything on one side. So I'm going to start moving stuff around. Now, I don't want x squared negative, so I'm going to move everything to the left-hand side. So when I move 5x over, I actually subtract 5x. So I'm going to bring down 2x squared, because it doesn't change. 6x minus 5x is just x. And then when I move 10 over, we actually subtract 10, so I'm going to put minus 10 equals 0. Okay, so this is factoring trinomial style, but it's long. So I know we haven't done this in a while. So we are going to multiply 2 times negative 10. That gives me a negative 20. Then I'm going to use this middle number. So the number in front of x is actually 1. So I'm going to look for factors of negative 20 that add to give me 1. And so I know that 5 and 4 give me 20. And if I want 1 to be positive, I need the smaller number to be negative. So we're going to use 5 and negative 4. Now, normally that's just our answers, but here we have to take this and plug it back in for x. So I'm going to bring down 2x squared, and then instead of writing plus x, I'm going to do plus 5x minus 4x, and then I'm also going to bring down my minus 10. Okay? And if you swap those, it will still, if you did minus 4x plus 5x, it will still turn out the same. So from here, we have 1, 2, 3, 4 terms. So when we have 4 terms, we group them in order to factor them. So I'm going to group the first 2 together, and I'm going to group the last 2 together. Make sure you group this negative sign in here, and I'm going to put a plus between. So my greatest common factor of 2x squared plus 5x is going to be x, which leaves me with 2x plus 5. My greatest common factor of negative 4x minus 10 is a negative 2, which would leave me with 2x plus 5. Now, if I did this correctly, my insides of my parentheses match, and they do. I have 2x plus 5 in both. So I'm going to take everything outside the parentheses, my x and my minus 2, and I write that in one set of parentheses. And then the 2x plus 5, I only have to write once. Okay. Now, for this one, it's easy to tell what x equals. For here, it's the opposite, so this would be x equals 2. For this one, it's not as easy. Some people know the trick. The trick is the opposite of the last number divided by the first. If you don't know that trick, I'm going to do it right here. So I'm going to take 2x plus 5 equal to 0. So this is how you would normally solve it if you don't know the trick. So I'm going to solve for x by subtracting 5. This gives me 2x equals 5. Then to get x by itself, I would divide by 2. 5 does not divide evenly by 2, so I'm going to leave this as, this should be a negative 5, negative 5 over 2. Okay, so now we have our x's, so we've got to use these to find measure OTL. So OTL, O to T to L, is this angle right here. Now, we're not given this one, but because this is bisected and these are both congruent, we know that x squared plus 3 times x is the same. So we're going to use x squared plus 3 times x. So if I plug in 2, that's going to give me 2 squared plus 3 times x. So 2 squared is going to give me 4 plus 3 times 2. Oh, sorry. 3 times 2 should be up here. So this would be plus 6, and so that's going to equal 10. So OTL equals 10. Okay, I'm not going to make you plug in the fraction. We'll just leave this as 10 degrees. All right? Hold on, let me go back, make sure you had time to write that down. The next problem we're going to look at is number 8. Okay, so let's look at 8. So 8 says, given that angle FEG is equal to GEH, so FEG is this angle right here. They're saying that angle is equal to GEH. So if these are equal, that means that EG is a bisector, okay? And G actually lands on the bisector, right? So they give me FG, the distance from this side to this point, is 10x minus 30. And then it tells me that HG, this length from H to this point, is 7x plus 6. Now, if this is an angle bisector and the length in the, there's a point that connects the angle bisector to this side, that means that these sides are congruent as well. Okay? Anytime angle bisectors are congruent, then that means from the angle bisector to the side is congruent, and vice versa. So that means that I can take 10x minus 30 and 7x plus 6, and I set those equal. Okay, so I'm going to solve for x. I'm going to subtract 7x first. That gives me 3x minus 30 equals 6. I'm then going to add 30 to both sides. This gives me 3x equals 36. We're going to divide both sides by 3. And x is going to equal 12. Okay, they asked me to find FG. So FG equaled 10x minus 30. So I'm going to take 12 and plug that in. So 10 times 12 is 120 minus 30 is 90. So FG equals 90. Okay, hint, 9 is just like 8. Angle bisector means, if we go all the way back, if these are equal, then these lines are equal. If these lines are equal, these angles are equal. I highly, highly suggest that you make note cards for angle bisectors and incenters. We're going to learn about a lot of centers in the triangles, and so it would be easiest if we made note cards to remember which one goes with what. Okay, the last example is going to be example number 10 and 11. So this one tells me, or the instructions for this tells me that TJ and SJ are angle bisectors. So TJ is right here, and let me scoot this over, and SJ is right here. These are angle bisectors. So that means that this angle and this angle is congruent because it's bisecting that angle. And then this angle, which they tell me is 14, and this angle is congruent, so this is also 14 degrees. Okay? They asked me to find the distance from J to RS. So J is right here. Now, J is the point that is connecting this angle bisector and this angle bisector. The point that connects the angle bisectors is the incenter. Okay? And so they want me to find from J to RS. So remember, when we go from the incenter to the side, we just go straight down because it forms, I didn't make that very straight, but it forms a 90-degree angle. Okay? And now, if we look back at our notes, it tells me that from the incenter of the triangle, it is equal distance to each side of the triangle. So if we look at this example, from the center to the side here is 8.37. So from the center to the side here should be the same. These should be equal. So from J to side RS, that's going to equal 8.37. Okay? And so if I did the same thing, if I went from J to RT straight down, that would also be 8.37. All of them are equal. Okay? The second thing they asked me for is angle RTJ. So if I go from R to T to J, I'm looking for this angle right here. Okay? So when you're trying to find pieces of angles like this, we actually want to look at the big triangle. So R is 42. S, this whole thing, is 28. So I know if this is 42 and this is 28, I can find this whole measure because I know that all angles in a triangle add to 180. So I'd do 42 plus 28, which would give me 70. Then I would subtract that from 180. So this whole angle right here is 110. Now I only want half of it. I'm trying to find half. So I'd take 110, and since they're congruent, we divide it in half. And so that angle would be 55. Okay, So you are now to do number 6, number 9, number 12, and number 13. Then you will take it to the sub, and they will mark you off to make sure you got all the notes, and then they're going to check your answers as well. Once you've done that, they are going to give you a classwork sheet, and the classwork sheet already has the final answer on it. I want you to show me how you set it up and got to the final answer. I went ahead and put the final answer on there because I wanted you to know what you were working towards so you would know whether you were getting it right or not. So work those out, make sure the answers match, and then if you finish that, you will start on IXL C5, and you are going to work that to 90. Whatever you do not complete from the worksheet and the IXL is going to be homework. So make sure you're really working and trying to get it all done so you don't have anything to do this weekend.